Good afternoon. Well, I have an opening question for you before we get into these $5 words like AI and MXDR and autonomous. How many people believe that autonomous driving will be dominant in the US in the next year? Got one hand. How about 10 years? Pretty healthy number of hands. 25? Does that get everybody? Okay. Just want to know who I'm dealing with. Audience sort of bent wise, and that's helping a lot. I know you're all IT professionals. Many of you are probably deep security professionals, but maybe not everyone. How many people know what a security operations center is? Okay, we've got an audience that's SOC savvy. How many people believe a SOC could be autonomous in 3 years? A few hands. How many would take the bet by 2030? Autonomous SOC. Okay, it's going to be an easy presentation because many of you are already at the end game. That's good. Okay, let's walk through this in some detail. I'm going to start you high and work down low. This is going to be very fast. It's only 30 minutes. Just to level set, we've been at an IT conference, but there's a fair amount of security presence here. Black Hat, RSA, earlier in the year. I know you're all aware of those events. If you just look at our industry big picture, Cyber Ventures says that the cyber crime market will exceed $10 trillion next year. Statista and Gartner had a similar number, so we're spending about $200 billion to try to stop the bad guys from achieving success. Simple math is a 50x. So you have to ask the question, how are we really doing? And I think the answer is it's still scary times. We could always say if we weren't spending $200 billion, this would be a much worse situation. Those numbers are not compelling, and I can guarantee you the number on the left is going to go up faster than the number on the right. Guarantee that. So let's look a little deeper. This will not be news for most of you, but it's good to just level set. There's 3 primary reasons why this is true. The first is if you're an IT professional and you're responsible for a network environment, an IT environment, an application environment, it's a huge, complex, very dynamic attack surface that you have to concern yourself with. Simple stat, mid-market focus, since that's where most of us live, almost 500 assets per employee in a mid-market organization. If you just think about that for a minute, that's a lot to be concerned about. In the middle, the bad guys are really good at what they do. They're well-schooled, they're well-trained, they're experienced, they're well-tooled, they're very motivated, and they're relentless, and there's a lot of them, and they're around the world. Then we have the defense, the other side of the football. Very small IT teams, typically we're anywhere from 2 people to maybe 20 in a mid-market organization. And you can start cutting that down by the number of people who can be applied to cybersecurity and that have real skills in that space. And for every asset that you have to worry about, on the order of 6 open vulnerabilities at any point in time. This is a very tough equation, and it still begs the question, which many of us have heard in cyber for years. Are we going to get a force multiplier? Do we need one? Is there one anywhere in sight? And I would argue that AI is possibly that force multiplier. Well, let's dig deeper. Okay, I'm going to go through very fast a typical attack sequence just to frame up what the bad guys are doing. There are 4 stages. The first stage is the attacker has to get into your IT environment. The pretty traditional methods, phishing email is still the dominant one. You're all aware of that. Phishing is the bane of our existence. Employees who don't carefully open emails or attachments is a tough and continuous problem. There can be malicious attachments shared between known entities in the organization. Clearly, there's still lots of software vulnerabilities, always will be. These are the 3 primary vectors by which the attacker will get in. Second thing they're going to do is, like any good criminal, they're going to establish a footprint. They're going to look for ways to get persistence. They know if they only reside on a single asset, you're going to out them and they're going to be exited. So they're going to look for ways to get into more places. They're going to escalate privileges, and at some point, they're going to command and control phone home for better instruction. The third thing that happens is lateral movement. Once they've established a beachhead, the game now is, let's see what you've got. What's in your network? What assets do you have? Where is the personally identifiable information? Where's the intellectual property? Where's the money? They're looking for all these places. They're going to identify those high-value assets, and they're going to try to compromise those systems. And then the 4th and final step occurs. This particular pictorial is a little geared towards ransomware. So there's going to be an exfil of some sort. And if it's ransomware, there's going to be a lockup of system or systems. and then you're going to get a phone call, and you're going to have a bad day. So that's the way this looks. It doesn't change very much from attack sequence to attack sequence. What's interesting is every one of those attack sequences has a clear signal. It's no different than a physical crime, robbery, murder, anything else. There's always tea leaves. There's always broken branches. There's always footprints in the mud. Those signals exist in the network. They exist on endpoints. If you're running your own workloads at Azure or AWS, they sit there. If you're running O365 or Google Workspace, almost everybody, one of those at least, there's signals there. We can go on. You can read this list. This is a subset, not a superset. But these are the kinds of things that we can see through telemetry every minute of every day. So it should be that we can catch the attackers early in the kill chain using military parlance before they complete their mission. Should be the case. There's plenty of signal. Let's look at it from the perspective of SOC analyst. This is what an analyst does every day. First, they have to find the signal in an ocean of telemetry coming at them. They got to weed out the false positives. Just one data point. We're mid-market, but let's think about enterprise. A typical enterprise firewall, just one edge firewall, can pump out 15,000 events per second. That's one edge network device. So you can do the math and you start thinking about the whole attack surface. You've got to weed out all that signal, and then you've got to find the ones that matter and contextualize them. You have to understand them with surrounding information. This takes time. You've got to prioritize that. I can guarantee you won't be dealing with one attack scenario at a time serially. They come at you in waves in parallel. Then you got to report your findings to someone who's going to make a decision to let you go forward. Then you have to draft something to do a remediation step. And you rinse and repeat, do this over and over and over again, and that's your job. Okay, to do this well, you need skill, experience. You need intel from machines, from artificial intelligence. You need it from human intel. You need a SOC. You need a lot of time. You need to do it around the clock. It's not for the faint of heart. So we are in the MXDR business, the managed extended detection and response business. I'm not really here today to give you a vendor pitch. If we have a booth, please come see us. Any detection and response solution should look similar. The way to read this slide is left to right. It's a game of bringing in as many different intelligence sources as you can on the left, including a large number of threat intel sources, paid, free, public, private, commercial, government, processing all that into a big washing machine that weeds out all the noise, finds the signal, contextualizes that, tells a human analyst what they need to know to make a decision on what is the nature of this attack, so that they can then do one of two things. Either recommend to your business, this is the attack we saw, this is the alert we saw, or alerts, this is what you should do about it, this is what it means, it's got to answer those questions. Or there's a fourth piece, which is, as a service provider, we will take that action for you. We'll go do the firewall rule change. We'll do an endpoint quarantine. We'll recommend you change something about a security policy. We'll tell you you've got really serious vulnerabilities sitting in Sector 6 tied to CVE XYZ. We can do that sort of active work for you. But this is the process that we have to work through. So the question is, this is a difficult job. How can we apply a force multiplier? And is that a realistic thing through AI? The way a SOC looks today is on the left. It's a room of some size. There's some big, sexy war room screens on a wall, but there's smaller screens and cubes, and people sit in those cubes, and they're doing their job, and they take coffee breaks, they get sick, they go to the dentist, and they have varying skill sets. The SOC of tomorrow, figuratively, is a very different picture. There are no graphical user interface screens because they're humans. You don't need that. You need a bunch of processing horsepower that comes in the form of CPUs, now, as we all know, more heavily centered towards GPUs and coming towards TPUs, tensor processing units, which are really, really good at super high computational parallel processing. You obviously need lots of power, and you need large language models. You'll need some form of AGI. It'll bend towards superintelligence. And you're going to need something called agents. Now, AI didn't just start in the cybersecurity world in the last couple of years. It's been going on for quite some time. And there have been phases to it from a technological point of view. dating, this is a conservative picture, they date back further, but we were using ML pretty aggressively in the cyberspace over a decade ago. And machine learning, both supervised and unsupervised, is baked into many security products in the detection and response space and other spaces. So that's not new. You're all familiar with ML, I'm sure. Then we saw a big dose of deep learning, which allowed us to go further than what ML on its own can do. We could start to see evidence of attack behaviors. We could start to peel back the intricacies of advanced persistent threats and other things. And then more recently, kind of post-pandemic, you might have heard the advent of predictive AI, being able to look at a battery of information that's been digested and neatly shaped and begin to say, if we see these conditions, this is what's likely to happen, even if the attack or the attack sequence step hasn't occurred yet. So that's kind of nirvana. Now, there's no security product from any vendor, not even the biggest brands in the industry, who have all three of these buckets solved 100%. Every vendor is on a spectrum of completion along this, and of course, completion is a moving target. But there was an inflection point, and that inflection point was about 2 years ago now, when ChatGPT 3.5 hit the airwaves and the world changed. The world changed in a big way. Immediately, we saw aggressive use of AI and GPT in the form of customer service automation, and in my field, content generation, to a fault, as we all know. Everyone became some form of a prompt engineer, good, bad, and different. We saw a marked change in the sophistication of AI phishing attacks. And of course, every boardroom is discussing serious questions around data privacy. How do you control this beast? What are the ethical uses of it? How do you know what employees should be allowed to do, what they are doing? How do you manage this from a corporate governance point of view? Those are all interesting topics in and of themselves. The picture on the right is particularly interesting because it tells us the progression of GPT models just in the course of a few short years. 3.5, and this is just an OpenAI chart, other LLMs have their own charts. But look at the transition of the number of parameters that these systems are working on. 117 million to trillions in the course of 5 years. To put it in perspective, a parameter is an identifier about an attack or something that we should. Let's use a really simple example. A lot of times when people talk about machine learning, they say, hey, I can give an unsupervised ML system a bunch of pictures of cats and a bunch of pictures of dogs. And in an unsupervised capacity, it's pretty quickly going to learn how to group those into cats or dogs. But it won't know what a cat or a dog is until you supervise and tell it this is a cat, that's a dog. At that point, it can identify pretty much anything. And if you give it a picture of a giraffe, it's going to know that it's not one of those two. If you take something as simple as a cat whisker, so a cat whisker, very small arm of a cat, it has attributes, it has parameters. There's a length to that whisker, there's a diameter, it has a column, it has a sort of tensile strength. It's surrounded by other whiskers. A lot of attributes of just a cat whisker. If we can nail down the behavior of, millions, billions, trillions of attributes around things like patents, protocols, human behavior, in certain systems, we can really have an LLM that goes deep on what looks like good behavior versus non behavior. So the power of LLMs is incredible. You probably have all had some experience with ChatGPT, but it's down to if you're good at writing prompts and if you have a good source of content, you can do astounding things. Break either one of those two rules, garbage in, garbage out. Here's what's more interesting. The advent of agents. So LLMs answer questions and they create things. Agents can do things. If you are that SOC analyst, there's no question, like any good engineer, anytime you do something more than once, you want to write a piece of code and do that for you. So every SOC analyst has written loads of Python scripts, nothing new there. With the advent of GPTs and other language models, we know that there is the ability now for these systems to do machine developed code on your behalf, to do much, much faster, much, much more accurately. How many people have heard of a company called Cognition Labs? Few hands. I don't work for them, I'm not promoting them, but at the beginning of this year, they came out with their own software agent, their own AI agent. Its name is Devin. With Devin, you can give it an objective. I want you to solve this problem. It will go out and use the same tools that a SOC engineer would do. You give it a plan of action, it will develop a code base. It will figure out the APIs that it needs to establish to go get information to feed that code base. It will run the code. It will find its own errors. It will write code to fix those bugs. It will repeat tests until it reaches a recursively strong solution. That's what Devin does. Now, that may sound pie in the sky, so let's just put that to the test. This is an eye chart. I'll give you a couple of really quick snap-ups in a moment, but there are a set of really, really good engineers, you can find this online, that develop something called SWE bench, software engineering bench. The question they posed was, can language models resolve real-world GitHub issues? They used about 2,400 real software engineering problems. They gave an LLM a code base and a description of the problem that needed to be solved. And it went about using complex reasoning to recursively solve the problem. You probably can't read that, it's too small, but let me give you the high and low points. In October of 2023, the best agents were able to solve about 1% of this problem set that's alive on GitHub right now. If you fast forward to just July of this year, 43%. Now, on one hand, that says 57% aren't solved yet. On the other hand, that's only 9 months with a certain vintage of LLMs. I shouldn't have to argue the point much beyond that. Let's take a second data point. Google has their own agent. It's called AlphaCode. AlphaCode is based on a version of Gemini, not the one that you have access to if you're commercially paying for it. AlphaCode 1 was put up against a Codeforce contest, which 8,000 human engineers have taken as well, and it scored in the 46th percentile in the late part of 2022. AlphaCode 2 was able to do very complex reasoning, and about a year later, it was in the 87th percentile. OpenAI 01, which just was announced last week, you can go to the OpenAI webpage, you will see this reference on the first page, a reference to Codeforce performance, and it solved into the 89th percentile. That's their first foray into this. That should give you pause. Now, let's go back to our SOC engineer's job. This is that sequence of steps they have to go through over and over again. Imagine you have the ability to break down the subtask inside of the find the signal work and write a script or have an agent write a script to solve that problem. And imagine applying agents to each step of this really arduous, false positive prone, laborious job burnout task list. And I think the conclusion you have to reach is it's not really a discussion around, are we going to replace the SOC engineers? He or she going to be out of a job in a matter of months? It really is a near-term discussion of, could that person's job description change dramatically in a very short period of time? And I would argue that soon a SOC analyst becomes an orchestral conductor of a set of agents. And he or she is asking these agents to perform a set of tasks. And then a new O-Day comes out tomorrow, and they have to go through this again. Eventually, they train the agents how to deal with even O-Day situations. So here's something interesting. There's a company called SmarterX. The link is in the chart. You can punch into SmarterX a job description, and it will tell you, based on an LLM output, what's the likelihood that this job function could be replaced by AI tomorrow. It's a pretty extensive prompt that they wrote to build this. You can actually use ChatGPT or reverse engineer it. You can see what their prompt is, about 8,000 characters. I took that prompt and recoded it around security analyst with average level of expertise. And this is the output it gave me. These aren't an exact mapping to the steps that I showed in the prior chart, but they're indicative. And to put the exposure level into context, E0 means that an AI agent could not do the job. So what's an example? We're here at an event. If I were to walk out of the audience and shake one of your hands and have a discussion with you, it's not something an AI agent can do today. Now, tomorrow, when we combine robotics, synthetic biology, quantum computing, and AI, you can have a different discussion. The Terminator movie will look like a cartoon, but that's a little ways off. But in this particular description, this AI agent or this LLM model says that You could replace 15 to 40% of this job description with AI agents. So you can punch in your own job description and play this game. I've done it with my job as a CMO, and it's not a pretty picture, but I have to deal with that. So that's reality. So the point here is, look at how far we're coming with code testing. Look at what the reasonable expectations are that LLMs can answer and tell us about what's the likelihood that particular job functions can be replaced and how soon. Okay, there's no black and white here. There's a spectrum. There's reason to be bullish that we can have an autonomous SOC very quickly. Here's some examples. If you believe in the rapid growth of LLMs, I think unless you live on a very, very large sized rock, you have to believe in that. If you believe that AI training costs for models are going to go to zero, if you believe that AI agents can start building their own automated threat intelligence, if you believe in extended contextual learning, if you believe that continuous learning can happen, today, training a model is a once every 3 month or 4 month event. This is a hugely expensive endeavor. But with RAG, we have the ability to train models on a more frequent basis, and that training cost is going to go to zero. So there's a set of reasons to be bullish that everything I'm proposing here could happen very soon. There's also a set of reasons to be bearish. Cyber threats are complex. Bad guys don't sit still. They're extremely creative. What we know today is not necessarily indicative of attacks tomorrow. There's still a high false positive rate. Human judgment is still required to step in and do a final analysis on what the machine has said. There are challenges in automation, and even if none of those are issues, we all work for a superior. And when you work for a publicly facing company, you deal with a board, and these boards are very worried about governance issues, compliance issues. What do you do when a neural network makes a decision about a cybersecurity threat, and it tells you take this action, and your boss says, good, we can take that action. As soon as you explain to me exactly how you arrived at that conclusion, a neural network cannot tell you that definitively, it can tell you that probabilistically. So that's an interesting thing to think through. All right, so if you've been in this space, you're an informed person about AI. And you're probably somewhere between excited and terrified. This is developed by Midjourney, so just an AI application. I would say the autonomous SOC is absolutely possible. It's even plausible. I would say there's strong reasons in the very short term to be bullish or bearish. But I would very definitively say the bad guys have zero downside. So we're going to face this defensively. Therefore, we have no choice but to be aspirational and try to drive that. How quickly can we adopt this and get a force multiplier?
For more information, visit gradientcyber.com.